How does axonal damage impact secondary progressive MS? Imagine a city where the roads are the nerve fibers carrying messages throughout the body. In multiple sclerosis, these roads get damaged, especially in the later stages called secondary progressive multiple sclerosis. This stage often follows an initial phase of relapsing-remitting MS, where flare-ups come and go. But in secondary progressive MS, the damage becomes more steady and less about sudden attacks. The key player here is axonal damage, which means injury to the nerve fibers themselves. In the early stages of MS, inflammation causes the immune system to attack the protective covering called myelin around the nerves. This demyelination can indirectly harm the axons, especially during active inflammation. During this phase, immune cells from outside the brain and spinal cord invade and releases substances like cytokines and free radicals that can damage axons. But these injuries are often temporary and localized. As MS progresses into the secondary progressive phase, the pattern changes. The blood-brain barrier, which normally keeps immune cells out of the brain, becomes less permeable. Instead of outside immune cells attacking, the damage is driven by immune cells inside the central nervous system. This leads to chronic, ongoing damage to the axons, even in areas that look normal on scans. Factors like mitochondrial dysfunction, oxidative stress, and microglial activation cause energy failure in the nerve fibers, disrupting their ability to function and survive. Over time, this results in axonal transection, meaning the nerve fibers are cut or broken, which causes permanent loss of nerve signals. This ongoing axonal loss causes the brain to shrink, especially in critical areas like the thalamus. As more axons die, the brain's ability to compensate diminishes, leading to worsening disability. This is why people with secondary progressive MS often experience a gradual decline in mobility, coordination, and other neurological functions. The loss of axons also means fewer nerve signals reach their destinations, making symptoms more persistent and less reversible. Treatments that work well in the early, inflammatory stages of MS, which target immune attacks, have limited effects on halting the neurodegeneration seen in secondary progressive MS. Protecting axons and preventing their degeneration is now a major focus of ongoing research. The goal is to slow down or stop the damage to nerve fibers, which could help reduce disability and improve quality of life for those with this stage of MS. In summary, axonal damage in secondary progressive MS results from a complex mix of chronic demyelination, ongoing inflammation within the central nervous system, and cellular stress. This damage is what leads to the irreversible neurological decline characteristic of this stage. Understanding and addressing axonal injury is crucial for developing better treatments and helping people manage the progression of their disease. Always consult healthcare professionals for personalized advice, as individual experiences with MS can vary widely.